Okay, now we did circles. We're going to do parabolas the next couple days, and then a quiz on Monday. So that means, and I know there's people gone at various points in time here. Now with the track meet tomorrow, I'm going to be out setting up and so forth for it. I'm guessing, depending when you run, some of you in track may still be here. I know the girls are running aren't out until noon, in the running events anyway. So it just depends when you're competing. I know we're also telling them that if they're, you're in a later event, you're not going to be running early in the day, even though you're dismissed, you should attend class. That would be obviously, I think, a pretty good idea. However, you'll just, and there won't be a video tomorrow because I won't be in here. However, I did make about a 15-minute video, which you probably wish I would do all the time instead of listening to my hour-long videos. But, I was talking to someone, I can't remember who I was talking to, who was listening to the video, and then, who was I talking to? And then it came up, and he was
oh, it's happened twice.
Yeah, well, with the music playing in the background. Yeah. Oh, there's the one with the music playing in the background. So somebody else was talking about the video, and I think it was in calculus, and I think John Brockmeyer asked a question about something, so we got off on this tangent that went for like 10 minutes. So they're listening to the video, and here's this tangent kind of going on, and then they're, oh, okay. And so but they didn't know when it was going to end, so they're fast forwarding and then listening. It was just, so I apologize for that. So anyway, I did make a little bit of a kind of a 15-minute thing over what's going to be gone over, kind of the homework problems as we check them and answers worked out, whatever. So if you won't be in here tomorrow, Mrs. Payne will be here, and she's, like I said, she's taught this before, and she will go through it with you. I've sent her the lesson plan and all the different problems and homework you'll have and so forth, and problems to go through with you. So it'll be as good or better than having me here, possibly. So that'll be that day, and then on Friday, I will be back, and there will be a video for that. I know Jake had probably gone Friday, right, with soccer. So, but my expectation would be, unless something strange happens, you'd still be ready to go on Monday with the quiz. Okay. I'll be here before school Monday, so if after all of that you still have some problems, still have some questions, I'll be here before school to get that taken care of. Okay?
Okay, so this is just an idea.
Yeah.
What if we took the quiz Tuesday? Because I'm going to be gone on Monday, and I've missed like every quiz.
That is a pain. So if I understand right what you're suggesting, you're saying let's rearrange everything.
Yes.
For you. Is that what you're saying? Because you're on crutches, we should feel some pity.
I just want some one thing.
Why are you going to go?
I have to go back to Lincoln for a checkup.
No, the quiz is going to be, I take that. My plan is still to have a quiz on Monday. I mean, I'll give it some thought. I will give it some thought. I mean, the downside of that is we will be going on to other stuff on Monday that is not on Monday.
Sorry, I said fine.
Sometimes that's okay. Sometimes that's maybe not okay. I don't know. So, I maybe we'll consider it. We'll see. Okay? Yes. All right. So let's go. We got a lot to get through, so we need to pick it up here. So you see the yellow around the room, and so let's get our partners. Let's figure out your partners. Go ahead and find your partners and go stand next to them.
40, 150.
Find them quickly. Let's go quickly. Move around. Find them.
Hold up, I gotta do quick math. I get it.
240. Okay, so everybody got their partner?
Yeah.
Taylor's doesn't have one. Okay, who's Addie with? 7x4s. How much is 7x4s? 315. Okay, there you go. All right, listen up here. Okay, Nick, you guys are group 1. You guys back there 2, 3, 4, 5, 6, 7, 8. You guys are 9, and then Taylor, you're 10. Okay, now up around on the wall you see the yellow circle. Okay, so whichever group number I gave you, you're going to go to that circle. Don't go yet. Okay, what you're going to want to do is maybe one person in the group bring a piece of paper Okay, and on the tables here, I have some facts about those circles. Now, in this order, well, I don't care the order, but this is how I'll look at your answer. I want you to look at that circle. I want you to write the equation. I want you to write the center. I want you to write the radius. I want you to calculate the circumference, the area, and then there's a brown point that is on, this point right here is on one of the circles. Only one. And there's another point that goes with it, the white, that is also on your circle as well. Okay? And that you'll have to kind of figure out by just looking at these probably. Okay? And so I want you to write those things down and then bring it to me so I can check it for you. Okay? We want to get through this as quickly as we can because we got a lot of parabola stuff to talk about. Okay, go.
Alright.
Now, when you calculate each of those, find it here and grab it, right? Because each one of each of these colors goes with your circle. So when you find it here, the equation, the center, the radius, grab it and hang on to it. The smart group will be the one that just waits till everybody grabs everything and then just takes whatever's left. Don't be that group. Huh? I know.
Actually, take a picture of it, bro. We have to use radius is 6.
Here we go. All right, get your notes out. So when it comes to circles of all the conic sections. Remember the other day we were talking about this cone, and we were talking about when you slice, straight across a cone, it creates a circle. Well, another shape that is created when you slice diagonally through a cone and down through the base, you get a parabola. Now, you guys have all worked with parabolas in Algebra 2 because a parabola is from a quadratic equation. And so we're going to talk about that. But circle is pretty simple. It's basically this equation right here. I think at this point in time, my thought is that I'm going to let you, against my better judgment, but what the heck, I'm retired, who cares? To let you use this sheet on the quiz. Mrs. Payne will just have a heart attack probably, and I'm going to let you do that. Anyway, I don't think it's really going to be, you're going to use it very much. I think after we practice them and working with them, that's the real key anyway. But this is the equation of a circle. Understand that the H and the K, which is going to be consistent as we go through all of our conic sections. The H and the K is an important point for a circle. It's called the center. Okay. The R, of course, is the radius. And most importantly, and probably the part that most students struggle with, is the X and the Y represent points on the circle. H and K are not actually on the circle. Remember, the definition of a circle is the locus or the set of all points equidistant from a given point. The given point is the center, but the actual circle is this part, right? And that's the X and the Y. The X and the Y are the points on the circle. So the way you would check to see, or if I told you, we'll do one of these later with a parabola, if I tell you that this point is on the circle, then that means you put the 7.38 in for the X and you could put the 4 in for the Y, and it should make that equation work. Okay, the H and the K are the location of the center. All right, now, here's what you know. I don't know that you need to write this part down. Here's what you should already know about a parabola. And I know I taught this in my Algebra 1B class. Now, we didn't do the completing the square part. But if you look at a parabola, and like I said, I don't know if you want to write this part down, but if I give you just a basic quadratic equation, y equals, you know that's going to be a parabola, right? That's what it will make. Now, if I do a complete the square, so this is something we talked about the other day. I don't know if you're going to have to do it much in your homework yet, but we will be getting into problems where you'll have to do it more. We talked about how you take half of this number, right, which is 2, you square it, which is 4, and that's the number we want to go right there. Now, we can't just change the quadratic equation by adding a 4 to it, so we've got to offset that by putting a -4 there. Okay, now, remember we talked last time about how you add 4 to this side, add 4 to the other side. Well, it doesn't do you a lot good to add 4 over here with the y. That doesn't do you much good. So we just add a 4 and then add a -4. And so it's like adding a 0. Okay, and then we take these 3, and that makes a perfect square, x plus 2 squared, and then these 2 make -7. Now, think about what we learned earlier this year with shifting and moving graphs around. What does this do with a basic parabola? Left 2, down 7, right? Left 2, down 7. So left 2, down 7, and there's our basic parabola. Another thing you learned back in Algebra 2 class was the vertex of a parabola is at -b/2a. And so I could have, instead of completing the square, this is how we would do it in Algebra 1b class, is we take -b, which would be -4, divided by 2 times 1, and we know that the vertex is going to be at -2. And then we could just make a table of values. -2, -1, 0, and we could plot and plot and plot, and then do the reflected, or what I call the mirror points, which are on the other side. And this is called your axis of symmetry, right down the middle. And voila, you have your parabola. So you could get it by just plotting some points. Okay, so this is kind of previous stuff that you've potentially probably done, maybe remember, maybe not, about parabolas. And it fits in with what we have done here with the shifting. But we're going to define it in this class a little differently. Okay, number one, we're going to take this -7, and we're going to add it over to this side, and we're going to write it like this. Now, you might think that seems kind of strange, that we would write it like this. Why wouldn't you want y equals? Well, here's why. We want to be consistent with all of our conic sections. So our circle, notice how our circle, we don't write y equals, right? We want the x and the y and the center point, the h and the k, we want those to stay with. So we know this is the x coordinate of the center, we know this is the y coordinate of the center. So when it comes to a parabola, we want to do the same thing. It's just another way of writing it. And so what we have here is like this is our h, because that's the x, and this is our k. But instead of the center of the parabola, what's the important point on a parabola? The vertex, right? So instead of the center on the circle, our h and our k are the vertex of the parabola. Well, what would the h be here? Same way you did it with these. -2, right? What's the h right here? 6. What's the k? -2, right? If it's a plus, it's opposite, right? That kind of thing. So what is our h? -2. What's our y? -7. So this tells you the vertex is -2, -7, which sure enough, there it was. You see what I mean? And so we're going to have that, still have that x minus h and that y minus k kind of a thing, just like we had with our circle. So we're going to be consistent. So this is a perfectly fine way to write a parabola equation, and that's how you did it in algebra class. But as we talk about it as a conic section, as a family of different kinds of shapes, we're going to write it this way. We're going to call this our standard form. Okay? We're going to call this our standard form. Now, only one of them is squared. It's the x that's squared, and it's the y that's not squared, right? Okay, so by definition, a parabola, this is the part of the parabola you have probably never talked about, okay? A parabola is a set of all points that is equidistant from a fixed point, which is called the focus. Anybody ever heard of the focus of the parabola? Did Mrs. Andreessen do that? I don't think she did, right? Yeah, I didn't think she would. From a fixed point called the focus and a given line, which is called the directrix, okay? Now, that picture you might want to draw, okay? That picture there you might want to draw. Now, it is on your notes, okay? It is kind of on your gold sheet, so it is up to you if you really want to write this all out. But it's the set of all points, a fixed distance from a given point, the focus, and a given line, which is called the directrix. And so if you notice, I've got this line drawn here, okay? And that is the same length as this line here. That didn't quite look like it, but close enough. Now, what that also tells you is that these two lines would be the same. Now, notice I labeled that P, okay? And so this distance from the focus to the vertex and the distance from the vertex to the directrix is going to be a value we're going to label P. Now, some books call it other letters, but we're going to call it, our book calls it P. Okay? All right, now, and that, again, is on that gold sheet that I gave you. Okay? And I'll come back to this here just real quickly. Oops, that's not what I was looking for. All right. Okay, so the construction looks something like this. Don't worry about this part, but if you did any construction in geometry, I'm just going to create a vertical line here, a perpendicular line here through point D. We're going to construct this segment here. We're going to construct a perpendicular bisector to that, so that means it cut these are equal right through here, and it's perpendicular. And then we're going to, and that created this point P right up here, okay? And what that created is an equilateral triangle, or excuse me, an isosceles triangle. So this side is the same as this side. So this is very much like the picture I just had up there. Okay, this point is equidistant from this line to here. We know that because we've got a bisector, so these two sides are the same. We know this angle is the same, and then this side is shared. So by side, angle, side, we have two congruent triangles. So these two parts are congruent, okay? Now, the parabola, and this is kind of cool here, the parabola then is the set of all points that keeps these two things the same right here. So as I drag P, watch what happens, okay? Oops. Come on. All right, well, I'll just let it go. All right, so notice this triangle. This triangle keeps these blue, right, these blue lengths the same, and look what happens. The set of all points that are the same distance from F as they are from this line, okay? And you can see pretty clearly there that that looks like, at least, a parabola. So that's another definition of what a parabola is, okay? And we could derive the equation, but it's a whole bunch of messy algebra. It's not awful. It's simply the distance formula. Now they call it R here. It's simply the distance formula with some squaring and some foiling. It's not awful.
Difficult number to
all right. Now, here's when you do all that awful algebra. Okay, once you do all of that, here's what you come up with, okay? You get, let me, okay. I thought I had, here we go. Okay, so we have now, look at the top line here, okay? So we now have here our standard form equation of a parabola. Now, notice the 1 over 4p. That's that number that I talked about. That is the distance from the focus, that point called the focus and the vertex, okay, and the vertex and the directrix. Now, we all know and hopefully remember that a parabola that faces up, if it's x squared or 2x squared, if that leading coefficient was positive, it faces up. If that leading coefficient was negative, it faces down. Okay, and so basically that's the P, right? If the P is negative. So this number in front is how we determine the shape of the vertex, or the shape of the parabola. That's the number that determines where our focus is, where our directrix is for that particular parabola. So our goal, the algebra we're going to have to do here, is to get our equation to look like that. That's our goal. Now, with circles, it was pretty easy. We maybe had to do a little bit of completing the square or something, and we didn't do a whole lot of work with that, but we did a little bit. And we'll do some more as we go. But whichever one is squared, we have this. Now, did you talk about sideways parabolas at all last year? A little bit, okay. So there are also parabolas that go this way. Now, they're clearly not functions. Remember we talked about the vertical line test early in the year? Obviously, sideways parabola does not pass that test. They're not functions. But it doesn't matter. There's still shapes, and there's an equation for them. And the only difference is we just switch the x and the y. We just switch the x, y. Now, we talked about doing that with inverse functions. Basically, that's what it is. They're like inverses. Okay? So notice it's the x that's to the first power, and it's the y that is the one that's squared. And that's how you tell the difference. A normal parabola is one where you have y and then you have x squared. That's the normal parabola you're used to. That's the top two. If it's the reverse of that, if it's x and then the y is the one that's squared, then it's this one. Now, if both the x and the y are squared, then you don't have a parabola. That's when you have a circle, or the other ones we're going to learn about, the ellipse, the hyperbola, those. So the parabola is easy to identify. It's one of the letters is squared and one of them is not. Okay? And that's how we tell if we have a parabola. Okay? But this is the form we're going to want to get them in. All right. Now, let's go back to just a couple of examples here. So if I had, for example, this one. Okay, so if I gave you this graph right here, or I gave you this equation, okay, I gave you this equation right here, okay, all right, so you look at that, you say, okay, which one of the four parabolas is this? Is it going to open up, down, right, left?
Down.
It's down. Since it's an x squared, it's our normal parabola, right, our normal up or down one, and since it's a negative in front, it's going to be the down parabola. Okay? Now, keep in mind our standard form. Since there's nothing with the 0, and there's nothing with the x, wouldn't it really be true that that one is that right there? Right? Is it right? Sometimes the ones with the 0 as part of the center or part of the vertex. I mean, much like this person who had this group that had number 1. You got x squared plus y squared. Well, that tells you that's 0, 0. Right? That's x minus 0 squared. That's y minus 0 squared. Okay? So since we have this right here, that becomes our standard form. Right? So right away we know our vertex is what? 0, 0. So I'm going to come over here and I'm going to plot that. You don't have to make a real fancy graph. You can just make it real rough on your paper. Just put an x-y axis, put a 0, 0 there. I'm not going to get real picky on those. Okay? Unless we get some graph paper. We may do some where we get some graph paper fancy. When we get into the ellipses and those, we'll get a little pickier about it. Now, the next thing that I would ask, though, is I would say, well, where's your focus then? Where's the focus on this parabola? Now, we know this opens down, right? We know this opens down. I'm going to go ahead and just do that, right? I don't even care how, if it's going through the right points. Right now, I don't even care about that. Just, we know it's going to do that. So down here somewhere is the focus. Right? The focus is always inside the parabola. And the directrix is always opposite that, or outside the parabola. So what I need is to find P. Right? Well, here's the secret to finding P. Is this right here has got to be the 1 over 4P. So what we're going to do is we'll go off to the side here somewhere. We'll write down negative 1/2 equals 1 over 4P. And we will simply cross multiply. Okay? Now, if this would have been a whole number here, if this would have been a negative 2 right here, we'd put negative 2 over 1. So right now, all I'm going to do is I'm going to cross multiply. I get negative 4P equals 2. Right? That's how you cross multiply these problems. Right? Now, I know when we were doing lost signs, we would just go here, here, and divide by this, but the problem is we got 4P down here. So we really can't do that. So what we really need to do is cross multiply. So negative 4P equals 2, and then what? Divide, and P becomes negative 1/2. Now, what does that tell me? That tells me for my focus, I'm going to come down here negative 1/2. Right? I'm going to come down here 1/2. And then for the directrix, I'm going to go up 1/2. And here's going to be my directrix right here. Remember, this is P, and this is P right here. So once we find the P, we've got the focus and the directrix on the map. Okay? Because of this picture, let me get to it. Because of this picture right here, right, we've got that. And if we go back to the original picture I had up here, right here, this is P, and this is P right here. All right? Okay, so what is that focus? Right there, the focus is 0, -1/2, and the directrix, what's the equation of that line right there? Horizontal line, is it y equals or x equals?
Y.
It's y equals 1/2. Y equals 1/2. Right? Now that's what those problems are going to ask for. They're going to ask for the vertex, the focus, the directrix. Now sometimes they'll also ask for the axis of symmetry. Well, the axis of symmetry is just this line that goes right down through here. The axis of symmetry is just this vertical line right down through the vertex. Well, what would that line be? X equals 0. Right? The vertical line right there is the line x equals 0. So sometimes the problem will ask for the axis of symmetry. And then it'll say graph it. Now, to really graph it neatly, you would plot a few points. You'd plot a few more points. But most of the time, I'm not going to care about that. I want to get the focus in there. I want to get the vertex or the directrix in there and just which direction it's going. Okay? And that'll be nice enough. Okay? That's how we're going to use this standard form equation. And again, the secret is that getting it into this form. That's number one. And number two, this number in front of the squared has to be 1/4p. Now, there are some places in your book, where they multiply this over to this side, and they write the equation this way. Now, it doesn't matter. They are the same, but I just, on my gold sheet, I made it this way. I like this better, okay? I like getting as close as we can to the y by itself. So this is just an alternate version, okay? It'll still find the p for you, but we're going to do it like that. That's how I'm going to show it. That's how it is on your gold sheet, okay? Now, I think when you look at them on the gold sheet, they've got this over there and the square over here. That doesn't matter, okay? I'm usually going to get it this way. Okay? All right. Well, what happens if you have one that is this way? Well, what's the difference here? The y is squared, so it's going to be one of those left or right ones. Well, which one's this going to open? To the right. Opening to the right is when it's positive. So when you see that 3/4 there, you know that that's positive, right? So again, this is like having x minus 0 equals 3/4 y minus 0 squared. So again, our vertex is going to be at 0, 0. Okay, our vertex is going to be at 0, 0. And so we know that. And then we kind of go off to the side somewhere and we take our 1/4p and we set that equal to what? 3/4. And now we cross multiply. What would that give me? 4 equals 12p. 4 equals 12p. And so p is equal to 1/3. So since p is 1/3, now which way do we say this is opening? It's opening to the right. So now, if I'm going to write this to scale, since those are 1, so that actually the focus would be right there. So since we know it's open to the right, remember the focus is always inside the parabola. The focus is always inside the parabola. So I'm going to go 1/3 that way, and I'm going to go 1/3 this way. And here's going to be my directrix. And we said that this is going to open to the right. And so it's just going to wrap around the focus right there.
What's the point of the directrix?
What's the point of it? The point of it is, the point of it is that's the definition. The directrix is a part of the very definition of a parabola. The points on the parabola are the set of all points that are equal distant from the focus and from the directrix. And so that's the point of it. That without it, you can't define what a parabola is, right? And so that's why we're getting it. So example, this point right here is the same distance from there as it is from there. And this point way out here is the same distance from there as it is to there. That's why the directrix is important. Okay? The farther away the focus is, the thinner the parabola is. The closer in the focus is, the fatter, the wider the parabola is. Okay? All right. So, anyway, what's the focus? 1/3 0. What's the directrix?
X equals -1.
X equals -1/3, because remember, vertical lines are x equals. And then the axis of symmetry would be right through here, which is, so if they ask for it, the axis of symmetry is y equals 0. So those are the parts of the parabola. Now, yeah, and then remember, what's the x and the y? The x and the y are the actual points on the parabola. All right, now, the reverse of that would be to write the equation. Okay? So let's take this one right here. So let's actually write the equation of this parabola. Okay, well, first of all, we have to notice, is it up and down or left and right? Well, it's up and down. So what's the, see if we can recognize this without looking at our gold sheet. What's the standard form of an up-down parabola? Y minus K always goes with the Y equals 1 over 4P
X minus H squared.
X minus H squared. Right? Now, on my gold sheet, I've got plus or minus 1 over 4P. Okay? But we just know this one's going to be plus, right? Because it's going up, and if it's down, it's negative. But I wouldn't even, even if this one was going down, I don't even think I'd have put a negative on here. The P will just come out to be negative. When I write my equation, I'll just have to make sure it's negative. Okay, if it went down. Okay, well, what do we know? With the information I've given you there, don't we know H and K? What are those? 0 and 0. So the H and the K are 0. What else do we know? What does this tell us right here? What is this distance right here? Yeah, assuming these are all going by 1. Isn't that 2 right there? -2, right? We get, but I mean, it's 2. But what is that? That's P, right? That's P. P is 2. So what does that mean? That means put a 2 right there. Well, what's this going to be right here? That's going to be 1/8 then. P is 2. So that means we're going to put a 2 right there. So what do I got? I got y equals 1/8 x squared. That easy. There's the equation of that parabola. As long as I know the vertex, H and K, and I know what P is, then I just plug it into my standard form, and I get it. So it's two types of problems that are really the reverse of one another. One is you have the equation. So you need to get the equation into this standard form. You need to make it look like standard form, because that tells you everything you need then. That'll tell you the H and K, it'll tell you the P. The reverse of that is to give you a graph which lets you figure out H and K and P, and then you just stick those in, and you got your equation, right? Those are really the two types of problems. Now, the difficulty lies in what information they give you. Here, it was pretty straightforward. Yeah. All right. So, last thing before we go here, okay? All right. So, write this down. So one of the difficulties will be that the problem is not in standard form. So you need to get it in standard form. Okay, well, what do we want with standard form? We want the x or the one that's not squared to be on the left. Now, it doesn't really matter. That's how I'm going to write them. And the one that is squared to be on the right. So this one, I better get over to the right. I don't want to distribute through that 6, because as we've seen already, we want these things to be in parentheses. We want them to be grouped. We don't want to distribute that. That will actually make things harder. Now, what else do we not want? That 6 is in the way, right? And so what we want to do is divide both sides by 6. So now we end up with this. Now, when you divide this whole thing by 6, isn't it really just like dividing the 2 by 6, right? Dividing the whole thing by 6 is really just doing that. And what is that then? Negative 1/3 parentheses y minus 1 squared. So one of our jobs today is to just get comfortable putting something into that standard form. Because once we do, all of our information is there. Now this is the 1/4p, so we can do our cross multiply thing. Here's our vertex. That's it. Once we got that, we're good. We can get our focus, we can get our directrix, we can get everything we want from there. Okay, so after lunch, our goal will be to work through some problems together as they get a little more challenging, and maybe have to do a completing the square or something like that, and then work on them.
So is that standard form?
That is called standard form. That is standard.
So if that was the question.
So yeah, if the question was put in standard form, you just stop right there. Yeah. Yep. problems. But if I make P bigger, in other words, if I move the focus further away, then the parabola gets wider, like so, and you can see the directrix move as well. So as P gets bigger, as P gets smaller, you go this way, and then as soon as P goes negative, then of course it flips, and then it's down. Okay, so you can just change the value, but that's how P affects the parabola. Okay, so that, again, the focus, the directrix. The H, well, that's just going to move the parabola horizontally. That just changes the vertex, okay, horizontally. And then the K, of course, just changes it vertically. So if you had, if you move H to a 1 and you move K to a 2, you have the vertex at 1, 2, right? And so that's that, okay? And then likewise, if you have the horizontal parabola, same thing. It's just x minus h. So I just switch the h and the k and the x and the y around. And again, same thing. The bigger you make P, the wider the parabola is, the smaller it is, the more narrow. Okay, and so forth. All right. So anyway, just getting comfortable with this form. So let's do a few more problems here. Just these are kind of the types that will be on the quiz that we'll be working on, and we'll work on again on Friday. So really, there's not much new about parabolas for me to tell you. It's more a matter of you getting a chance to work through the problems and practice the completing the square, all those different things. So let's say we had a problem like this that said, okay, here's a parabola, and it has these two components, the vertex and the focus. You write the equation. Okay? So, again, you don't have to make a fancy graph. I've got a nice grid and everything here, but if I was doing it, I would just go, okay, 0, 0, and 2, 0. Well, right away, just by plotting those 2 points, that tells me what about the parabola? It opens to the right because the parabola has to wrap around the focus, right? It has to. And it also tells us what then? P is 2, right? So now we got everything we need. We got the vertex is here at 0, 0, right? And now all we need is, and you got the gold sheet right here. I mean, that's why I just feel awful letting you use the gold sheet. I don't know. Maybe I'll change it. I don't know. But which one is this? This is the sideways parabola, so it starts with what? X minus 0 equals 1 over 4p, but p is 2, so it's 1/8. Now, is it negative or positive? Positive when it opens to the right. And then y minus 0 squared. I'm perfectly fine if you leave it like that. If you want or prefer to just do that, then that's okay too. Okay, but I am okay if you leave it like this. Okay, and so it's just a matter of knowing your standard forms, which one goes with which, and what P is, and so forth. So really, some of these are not terribly difficult. Okay, let's do this one. This one gets a little tougher because now we're going to have to do this thing we talked about with completing the square and so forth. Okay, so we'll get into this here a little bit. Okay, so let's say we have this equation right here, which is clearly a parabola. It's got y and it's got an x squared, so it's going to be one of our up-down ones. Actually, we already know it's what? Negative, the negative 1/2, so it's going to be a down parabola. That's based on stuff we've learned before. But now they want us to find the focus, the vertex, the directrix, and the axis of symmetry. Well, now that's a matter of getting it into standard form. Getting it into standard form. So that means we're going to want the y over on the left side, and we're going to want the x squareds over on the other side. But we're going to have to get it into this form, so we're going to need to complete the square. Okay, now the first thing I would do when I see fractions in one of these problems is I would multiply through by the denominator to get it out of there. So I would take everything in this problem by 2. So turn this into 2y equals negative x squared minus 2x plus 1 is what I would do with this right away. Okay. The other thing I would do is before I complete the square, we really want to have a 1 in front of the squared term and not a negative. So the other thing I would do, and probably should have done it right away, is I'd have multiplied by a negative 2. So let's turn everything opposite. So that'd be negative, this would be positive, positive, and the 1 would be negative. So really I wanted to multiply everything by a negative 2. Okay? Now, that means I want to keep the x squared and the 2x on this side. Right? This is probably, completing the square one's probably one of the things we'll probably have to spend the most time kind of trying to practice, because not that it'll happen in a ton of problems, but we want to do it. I'm going to move this negative 1 over here. Okay, so that's going to be negative 2y plus 1. So I'm going to get my y over here with this, and now I've got my x's over here. Now I'm going to do my complete the square thing. Okay, now, so I'm going to need to put something in here, and then I would say I'll put something over here as well. I'll put it on both sides. Remember we talked about that? One way to do it is add it and then subtract it. Or if you've got two sides of your equation, you can add it to each side. So what are we going to want to put right here? Plus 1. We take half of the 2, remember, half of this number, and we square it. So half of 2 is 1, we square it as 1, and then we need to add 1 over to this side. So we now have negative 2y plus 2, and these problems are going to be made to work out nice for you. And then this side over here is x plus 1 quantity squared. X plus 1 quantity squared. So again, I wanted the squareds to stay over on that side, the non-squared on the other side. Now, the other thing I need to do is divide, and I need to get this as just a y. Remember, our standard form just has a 1x or a 1y. So I'm going to take out a negative 2. So I'm going to take out a negative 2, and that gives me y minus 1. And over here I've got x plus 1 squared, and I'm almost there. I've almost got what I want. What else do I need to do? Divide by negative 2. Divide by negative 2, so that gives me y minus 1 equals, and then I get, when I divide by negative 2, now I don't want to divide the whole thing by negative 2, I'd rather write it as a negative 1/2, right? Dividing by negative 2 is the same as multiplying by negative 1/2, and then I got x plus 1 squared. And now I've got it in that form. So, like I said, the thing that's the most algebra intensive is getting the equation into standard form. Now, it's nice when they give us one that's already in standard form. That's great. Thank you. Right? Save me some steps. Or it's nice when I got one that's almost in standard form. Right? The squared, that was already completed for me. This is already, 6 is already factored out. All I had to do is kind of move some things around. Right? So they've already done a lot of the work for me. Here's one where you've got to do more of the algebra, okay, to get it in the form you want. So this is where all that algebra stuff you did in Algebra 1, Algebra 2 kind of pays off in being able to get in this form, because now we know all kinds of stuff, right? The only thing we don't know yet is p, which we can get by doing what? Negative 1/2 equals 1 over 4p. This is where we do the cross multiply thing, right? If we've got it all set up right, the fraction or whatever number is in front of here. Now, maybe it's a 1. Maybe there isn't a number there. If there isn't a number there, it's a 1. And we would put 1 over 1 equals 1 over 4p, because we still have to find p, right? We always have to find p, because that tells us where to go from our vertex so we can find our focus and our directrix. So anyway, we cross multiply here, we get negative 4p equals 2, so we get p equals negative 1/2, is that right? Now we've got everything we need. We got our vertex, where's our vertex? Negative 1, 1, remember, don't forget, x has to be your first one, so you got to find your x over here. So it's negative 1, and then 1. Okay, so you got to go x for the x coordinate, you got to go to the y for the y coordinate. So there's negative 1, 1. We'd already determined that this was, or no, I guess we did. Yeah, we did. It was going to open where? This was going to open because of the negative, right? So we already know this is going to open down. So I'm saying go ahead and draw it. I don't care how accurate that part of it is. Okay? And p is negative 1/2. So that means our focus is going to be right there, down 1/2. And our directrix is going to be there, up a half. And there's our directrix. And now it's just a matter of writing it out. We've got it all there. It may not have said to graph the equation, but I think graphing the equation is the key to writing the answers correctly. So, vertex, -1, 1. Focus, what? -1, no. -1, 1/2, right? We came down a half here. Right now, if you don't have a grid, if you don't have graph paper, your graph might have just looked like this. You would have went -1, 1, and then, you write in a half here. Just remind yourself that that distance is a half, that distance is a half, right? I mean, if you don't have grid paper, you'll have to pay attention to what those numbers are. Okay, so that's -1 and 1/2, and your directrix, y equals 1 and 1/2, or 3 halves, I don't care, either way. Y equals 1 1/2, or y equals 3 halves. Okay, and then it did ask for axis of symmetry, so that's going right down through here. What's that? X equals -1, right? But the whole key was getting it in standard form, which lets us find our p-value. And then, of course, by getting into standard form, we have a vertex. Once we have a vertex, our p-value tells us everything else. That's it, okay? So, but again, the algebra is the key part of that. Okay, so we already did kind of that scenario. So let's go through one last thing so I can give you a little bit of work time. You don't need to write this down. Let me just ask you a couple questions here. Oops. Okay, so which way would I slice this to get a circle? Straight across, horizontally, like so. That would give me a circle. What about a parabola? Right? Diagonally like that, or diagonally up here, right? Slice that, that would give me a parabola. Ellipse, remember that one? Right? That's that one right there. The oval. It's like the circle, except not horizontal. Come through here at an angle like that. That would give you an ellipse, right? And not go through the bottom. And then the hyperbola was the one that goes straight down like this. That's this one on this side over here. Right? Peel that off. That's one branch. The actual hyperbola would have 2 branches. It looked like 2 parabolas opposite each other. Okay. All right. So just a little review of that. Okay. What if we had to do a kind of a matching thing? If you were going to do a matching thing here where you had to match these graphs with these equations, let's just take this one right here. Okay, so say you had to match A here with one of these equations up here. What part of it would you look at first? Which way it's facing, right? Which means it's got to be an x squared or a y squared. X squared. Isn't x squared the normal kind of parabola that you're used to doing? Isn't x squared the normal up and down? It's got to be a y squared. Okay, it's got to be a y squared. So that eliminates, right? That eliminates all the ones that are x squared. And it opens to the right. Okay, now they're not all written in the format we would necessarily write them. So you got to be a little careful. Here's what I was getting at, I guess, is I would think you would focus in first of all on this vertex. It looks like it's at 3. Looks to me like it's at 3, 1. Right? Wouldn't that be a good way to eliminate choices? Look for that vertex, 3, 1, and it's got a y squared. Things like that. Okay, so those would be some ways you could do some of those. And then right here it says find the standard form equation of a parabola with the given characteristics and the vertex at the origin. So there's a whole bunch of problems, but they tell you the vertex is at the origin, so that makes it a little easier. And then they give you the focus or the directrix, or they give you other things. But the last thing I want to comment on is, let's say one like 29. It says it's at a vertical axis and it passes through the point 4, 6. So let's say we had a problem that you know has this at the origin, has a vertical axis. What's that tell you? It either goes up or down, right? It either goes up or down. And it passes through the point 4, 6. Well, what's that tell you? it goes up, right? Vertical axis, we knew meant it goes up or down. The fact it passes through the point, oh man, that's awful. 4, 6, that's even worse. The fact that it passes through 4, 6, right, tells us that. Okay, now, what would we do with that information? Well, we know since it goes up that that's this standard form right here, right? Right? We know it's the x squared version. So we know it's got to be that. And we know that 0 and 0 would go there. But in those other problems, they told us the focus, which allowed us to figure out P. Or they told us the directrix, which allowed us to find P. Okay? What are we going to do with the 4, 6? Where do we put points that are on the parabola? For x and y. And again, that's why I was saying that's a point a lot of people forget about. Points on the parabola are the x and the y. So what do? You put a 6 right there, you put a 4 right there, and that's going to allow you to find what? That'll allow you to find P, because now you know all the different unknowns except for P. Now you can find P. Okay? And then once you find P, then you can write your equation. Then your equation is going to be, once you find P, you'll have that value, and then you'll have x minus, oops, let me square, x minus 0 squared, and once you find P, you'll know what number to put in there. Okay, and the problem was write the equation, so when you write the equation, you want to take those numbers back out, put x and y, and you leave the h and k in there, but you have x and y for your equation. Okay, so that's something to keep in mind. Points on the parabola go in for the x and for the y. All right, so those are your problems to do. Okay. So once again, if you know you won't be in here tomorrow, you need to get a worksheet from me. But that's not all that you will do tomorrow. And so you'll need to look at the video. You'll need to look at the little video. It'll be posted as April 5th, right? I'll put today's video on there as April 4th. I'll post tonight, or this afternoon already, I'll post the other one. So if you know you're going to be gone, tomorrow after you do the homework tonight and want to get that taken care of, again, you can do it tomorrow night or whatever. But you can look at that. There's some book problems we'll be doing during class, and then there's a worksheet. So before you leave, if you know you won't be here tomorrow, make sure you get the worksheet from me, okay?